Welcome back. Today we're going to be working on 7D, which is dividing with negative exponents. So first things first, let's go over the content objective. Students will be able to evaluate expressions by dividing with negative exponents. Language objective is students will be able to discuss ways of breaking apart expressions and then simplifying the expressions using mathematical properties. And why am I learning this? Well, it's important for real-world problems like determining how many bacteria exist after one bacterium reproduces multiple times. So first we're going to go over some background knowledge. Recall when we were dividing exponents in the past, when we were just working with positive exponents. Let's see what happened here. So first you went ahead and extended out each term. So 5 to the 6 is 5 repeated 6 times, and 5 to the 4th is 5 repeated 4 times. And then you went ahead and reduced as much as you could. So here I can go ahead and reduce each numerator and denominator by 5 until I can't any further. And then you would go ahead and give your final answer. In this case, I'm left with 2 5s in the numerator, so that would be 5 squared. Which, if I was asked to evaluate, which it does say here, you would go ahead and multiply. 5 times 5 is 25. So now going over some more background knowledge. Some of you can recognize right away what 9 to the negative second is. Some of you can just automatically say, oh, that's just 1 over 81, which is great. But just a quick reminder, how do we actually get that answer? Well, it's because we understand that negative exponents mean repeated division and positive exponents means repeated multiplication. So in this case, since we do have a negative exponent, we're going to do repeated division. So we're going to start with a 1 and we're going to divide by 9 2 times. So from there, you can go ahead and say, okay, well, I can simplify 9 squared, that is 81, so that's equivalent to 1 over 81. So notice no matter which way you see it, you're still going to get the same answer. This is a quick way of seeing it, but this explains how you actually get your answer. Okay, so let's go ahead and jump into our very first example with dividing exponents that have negative exponents. So here, let's remember, what do negative exponents represent? It represents that we're going to do repeated division. So in a case like this, since 7 is being raised to a negative exponent, I know I'm going to do repeated division. So here I'm going to start with a 1 and I'm going to divide by 7 to the 9th power. So essentially I'm rewriting 7 to the negative 9th as 1 over 7 to the 9th. So these are both equivalent. Okay, so now we're going to go ahead and do the same thing to the denominator. And why am I doing this? Well, because the denominator is also raised to a negative exponent. So I'm going to go ahead and rewrite 7 to negative 6 as 1 divided by 7 to the 6th power. So you're doing repeated division. You're going to do 1 divided by 7 6 times. So again, note here that we are essentially rewriting 7 to the negative 6th as 1 over 7 to the 6th. So these are equivalent. So now here we have a complex fraction. So we've dealt with complex fractions before. We just say that this technically means 1 over 7 to the 9th divided by 1 over 7 to the 6th power. Here, since we are dividing fractions, we're going to rewrite this as 1 over 7 to the 9th times the reciprocal, so that's 7 to the 6th, over 1. Now multiplying straight across, 1 times 7 to the 6th power is just 7 to the 6th, and then 7 to the 9th times 1 is just 7 to the 9th. At this point, then comes the tedious work of writing all of the 7s out to see how many get reduced. So here, I'm going to write 7 to the 6th as 7 repeated 6 times, so 2, 3, 4, 5, 6. And 7 to the 9th is 7 repeated 9 times, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So once you've done this, what you're going to do is go ahead and reduce by 7s. 7 divided by 7 is 1, and you're going to continue this until you have no more left. Okay, so at this point, I can see that I'm basically left with 1 times 1 times 1 times 1 times 1 times 1 in the numerator, which is just 1. And how many 7s do I have in the denominator? There's 3, so I'm going to put 7 cubed. So this is part of my answer if they were to ask me to write in exponential form. However, if they asked me to evaluate, I would take it a step further and say that is 1 over 343. So you just need to be careful and make sure that you're answering the question. Are they asking you to leave it in exponential form, or are they asking you to evaluate? Now, real quick, I want to backtrack to this. 7 to the 6th over 7 to the 9th. So if we have 7 to the 6th over 7 to the 9th, there's technically a quicker way of doing this. First, you should be asking yourself this. We understand that you're going to reduce as many 7s as you can, right? Which means at one point, either the numerator is going to run out of 7s or the denominator is going to run out of 7s. One's going to run out before the other. So what you should be looking at is this. Are there more 7s in the numerator, or are there more 7s in the denominator? I would say in the denominator, right? Because there's 9 in comparison to 6. So obviously 6 of them are going to reduce. So how much would I have left in the denominator? I would only have 3 left. And here, since there was less, all of these would be reduced, leaving you with just 1. So what you can start doing now, because this is going to be your answer, what you can start doing now is understanding this. Are there more 7s in the numerator, or are there more 7s in the denominator? There are obviously more 7s in the denominator, so there's going to be still some 7s left in the denominator. Then you should be asking yourself this. Well, how many more 7s are there than in the numerator? Well, since there's 9 here and 6 here, I would say there's 3 more. Then, of course, where there's less, you're going to have 0 left, so anything to the 0 power would just be 1. So that's one way of thinking about it. It's going to save you some time. However, if you feel more comfortable writing out all the 7s, totally do that until you finally develop the pattern and you're able to do it a little bit quicker. Okay, so now returning back to the actual lesson, let's go ahead and try some more examples. Okay, so here we have 4 to the negative 5th. Definitely want to simplify that. Since it's raised to a negative exponent, I'm going to do repeated division, so it's going to be 1 over 4 to the 5th. Now, what about the denominator? Well, the denominator also has a negative exponent, so I'm going to do repeated division there. So it's 1 divided by 4 cubed. So here, this is going to be rewritten as 1 over 4 to the 5th divided by 1 over 4 cubed. Now we have some fractions and we have a division problem, so what we're going to do now is rewrite this as 1 over 4 to the 5th times the reciprocal. So I'm going to go ahead and flip this fraction over and write it as 4 cubed over 1. So multiplying straight across, I have 4 cubed in the numerator and 4 to the 5th in the denominator. So once again, if you feel more comfortable writing all the 4s out and actually reducing them, great. That's totally fine. But to speed things up and to get used to it, ask yourself this. Well, do you have more 4s in the numerator, or do you have more 4s in the denominator? Hopefully you say there's more in the denominator. Well, how many more 4s are there in the denominator than there was in the numerator? Well, since we have 5 here and 3 up here, there's obviously 2 more that won't get reduced. So in the numerator, since there was less, all of them get reduced down, and you're left with, if you remember, reducing, you're technically left with 1, which you could think of it as 4 to the 0 power, because there's no more 4s left, is also just 1. But again, feel free if you need to totally write the 4 cubed out and then write 4 to the 5th out. So you notice there's the 4, and then you had to add 2 more to make 5. And these would reduce to 1s. So just to further prove my point. This is going to save you some time, but again, do it once you're comfortable with what it all means. Taking a look at number 2. Once again, we're going to check, since we have a negative exponent here, we're going to do repeated division, so that's going to be 1 over 2 squared divided by a 2 cubed. This basically means 1 over 2 squared divided by a 2 cubed. Now, to keep things nice and clean, I'm going to go ahead and write 2 cubed as a fraction, so I'm going to put it over 1. Now you'll notice I will always write this next step underneath the original, and the reason why I do this is to help remind me to make sure I'm changing division to multiplication, and also to make sure I'm taking the reciprocal, because that's often the most common mistake is students forget to take the reciprocal of that second fraction. So now this is going to become 1 over 2 cubed. So multiplying straight across, 1 times 1 is just 1. And here we have 2 squared and we have 2 cubed. So altogether we have 2 to the 5th power. So notice here, I didn't have to compare the amount of 2's in the numerator versus the denominator because there was no 2's in the numerator, which means that there would be no 2's that would actually reduce in the numerator and denominator. So this is going to be my answer in exponential form, but since they asked me to evaluate as well, I'm going to go ahead and multiply out 2 5 times, and that's going to give me 32. So my answer evaluated would be 1 over 32. So now looking at number 3, here we have another negative exponent. So what I'm going to do is do repeated division. So it's 1 over 8 to the 7th power. And here yet we have another negative exponent, so we're going to write it as 1 over 8 to the 7th power. What does this all mean? It means 1 over 8 to the 7th divided by, because that's what the fraction represents, 1 over 8 to the 7th. Then of course we rewrite this as 1 over 8 to the 7th times the reciprocal, so I'm going to take this fraction and flip it over to 8 to the 7th over 1. So now we have 8 over 7, 8 to the 7th over 8 to the 7th. Here, since we have a base in the numerator and in the denominator, we can go ahead and compare. Do we have more 8's in the numerator or more 8's in the denominator? Guess what? We have the same amount. So what happens when we have the same amounts? Well, they're going to cancel all in the numerator and cancel all in the denominator, leaving me with nothing. So it's 8 to the 0, which is 1. Now, if you don't believe me, what you could do is go ahead and write it out. 8's repeated 7 times. 1, 2, 3, 4, 5, 6, 7. Divided by 8 to the 7th, so 8 repeated 7 times. 1, 2, 3, 4, 5, 6, 7. And then you can see they can reduce and leaving me with a bunch of 1's because 8 divided by 8 is 1. Okay, so either way you see it, you're still going to get the same answer. Now, I know what some of you are thinking. You're probably thinking since the beginning, 8 to the negative 7th divided by 8 to the negative 7th. You're dividing it by the same number, and we know anything divided by the same number is just 1. So let me give you an example. 8 divided by 8 is 1. 9 divided by 9 is 1. 9,200 divided by 9,200 is 1. Anything divided by itself will always be 1. So was it necessary for me to go through all that steps? No, but I went ahead and showed you so you can see what you would do when you have negative exponents anyways. So if you understand anything divided by itself is 1, totally save yourself that time and write the answer 1 without showing all of the work. Moving on to number 4, let's see. Here we have 1 divided by 3 to the negative 2nd. So here, since we can't do anything with 1, we're going to leave it as that. Then here, since it's a negative exponent, I'm going to go ahead and do repeated division. So this is 1 over 13 squared. So hopefully you start recognizing, oh look, 13 to the negative 2nd is the same as 1 over 13 squared. Okay, so that might help save you some time as well if you start recognizing, oh, that's what's happening every single time. Now here we have a messy fraction, so we're going to clean that up a bit. We're going to do 1 divided by 1 over 13 squared. So just because this one's a fraction, I think it's going to be a little bit easier to make things cleaner if I make 1 as a fraction as well. So I'm going to go ahead and write it over 1. So now that we have that, I'm going to rewrite it as 1 over 1 times the reciprocal. So again, a lot of my students are forgetting to take the reciprocal, so please make sure you're checking that you're doing that. So I'm going to go ahead and write 13 squared over 1. So multiplying straight across, I'm now left with 13 squared over 1, but anything over 1 doesn't isn't going to change the number, so I'm just going to go ahead and leave it as 13 squared. So this is my answer in exponential form. But if I was asked to evaluate it, I would say 13 times 13 is 169. So again, make sure you're answering the question. Here it does ask for exponential form and to evaluate. So those are my two answers. Okay, keep moving on. Number 5 is very similar. We've done this type of problem already, but the only thing you want to be careful about is recognizing that in this case, my base is a -3. So let's try it out. Here we have -3 to the -6 power. Since it's a negative exponent, I'm going to rewrite it as 1 over -3 to the 6th power. I'm going to go ahead and keep this fraction bar here. Well, this is -3 to the -4th power. Since it's a negative exponent, you're going to do repeated division. So it's 1 over -3 repeated 4 times. So to clean this up, I'm going to go ahead and rewrite this as 1 over -3 to the 6th divided by, because that's what this bar represents, 1 over -3 to the 4th. So now we can go ahead and rewrite this as 1 over -3 to the 6th times the reciprocal. So if you don't know, reciprocal is basically taking the flip version of your fraction. So now I'm going to have a -3 to the 4th over 1. So this is going to leave me with a total of a -3 to the 4th over a -3 raised to the 6th power. So again, you can definitely extend this out completely and reduce as many -3's as you can, or you can start comparing. Where are there more -3's? I'm going to say definitely in the denominator. So there's obviously going to be some -3's left in the denominator. But how many will be left? Well, if we have 6 in the denominator and we have 4 in the numerator, there's 2 more left over. So we're going to go ahead and square that. But since there is less in the numerator, they will all be reduced down, leaving us with just 1. Or again, you can think of it as -3 to the 0 power is just 1, because all of them would be reduced. But if you have no idea what I'm talking about, you can go ahead and write -3 written 4 times, and then -3 written 6 times. So here is the 3 that's going to cancel out. But you need 6, so you need to add 1 and 2 more. So again, you can see that's how you would have 2 more. Okay, so that would be my exponential answer, but you also need an evaluated answer according to the instructions here. So my answer would be 1 over +9. Why positive, not negative? Because a -3 times a -3 is a +9. Okay. So let's try one last example, and then I'm going to actually have you try some on your own. So for number 6, here it's the opposite of 4 to the -2nd. Well, since it's a negative exponent, I'm going to go ahead and do repeated division. So that's 1 over the opposite of 4 squared. Now I'm going to keep this fraction bar exactly where it is. And here, since it's a negative exponent, I'm going to do repeated division again. So I'm going to do 1 and repeatedly divide the opposite of 4 times. So once I have this, I'm going to rewrite it as 1 over the opposite of 4 squared divided by 1 over the opposite of 4 to the 4th. Of course, I'm going to rewrite this, which is going to become 1 over the opposite of 4 squared times the reciprocal. So I'm going to go ahead and rewrite this as the opposite of 4 to the 4th over 1. So now this is going to leave me with the opposite of 4 to the 4th over the opposite of 4 squared. So notice here, my base is not a -4. My base is just 4, and we're taking the opposite of it. So because of that, I can go ahead and figure out right now, is my answer going to be negative or positive? Well, negative divided by negative is a positive. So I know for a fact my final answer is going to be positive. Okay, so with that, let's figure out how we're going to simplify this. Well, are there more 4's in the numerator or are there more in the denominator? Since we have 4 in the numerator and 2 in the denominator, I would definitely say there's more in the numerator. Well, how many more are there? There's 2 more. So I'm going to go ahead and write 4 squared. So now there's absolutely no more left in the denominator because they would all be reduced down. So that's 4 to the 0 power, which is just 1. So we wouldn't leave it like this. We would actually write it as just 4 squared. So that's going to be my exponential answer. But this, in evaluated, would be 4 times 4, which would give me 16. Okay, now one thing, again, this is the last time I'm going to show you. If you needed to write this out, you would have written 4 times 4 times 4 times 4 over 4 times 4. So again, you can see that these will reduce down to just 1, and you see that you do have 2 left over. So do what you're comfortable with, but start recognizing that pattern, because it's going to save you some time. Okay, so on this note, I'm actually going to have you pause the video and go ahead and try all the problems all the way up to number 13 by yourself. Okay, so let's see how well we did. Number 7, hopefully you went ahead and wrote -7 out 4 times and -7 7 times. Hopefully you saw that you had a positive exponent, so you didn't have to do repeated division. So please don't always get caught up into, oh, I've been doing repeated division this entire time, so I'm going to continue doing that. No, please make sure you check. Is it a positive exponent? If so, repeated multiplication. If it's a negative exponent, oh, I'm going to do repeated division instead. So please make sure you're checking for that. So here, again, you can ask yourself, is there more 7's in the numerator or are there more -7's in the denominator? And hopefully you said there's definitely more -7's in the denominator, so you'd be left with 1 over -7 cubed. But if you need to totally write it out, there's nothing wrong with writing it out. It actually helps cement the idea of what you're doing and why you get the answer that you get. Okay, so the answer is 1 over -7 cubed. Now, quick reminder, do you need those parentheses around the -7? Absolutely. Without that, you would technically read it as 1 over the opposite of 7 cubed. So make sure you're writing parentheses when necessary. Okay, so since the instructions also ask you to evaluate, -7 cubed is going to give you a negative answer. So it's -1 over 343. Okay, looking at number 8 here. 1 is going to stay the same, but 5 to the -3rd, you're definitely going to do repeated division there. So that's going to leave you with 1 over 5 cubed. This is going to be rewritten as 1 divided by 1 over 5 cubed. Notice automatically we put 1 over 1 to make it a fraction so that when we are dividing those fractions, it's easier to work them out. This is going to change to 1 over 1 times the reciprocal. So again, reciprocal is taking the flip version of this, which is going to leave me with just 5 cubed. But because we're also asked to evaluate, 5 times 5 times 5 is 125. Number 9. Here, you could have totally worked it out yourself, or you can know, hey, 7 to the -6 divided by 7 to the -6 is just 1, because anything divided by itself is always 1. But if you had to, hopefully you rewrote it as 1 over 7 to the 6 divided by 1 over 7 to the 6. You rewrote that as 1 over 7 to the 6 divided by 1 over 7 to the 6, which you would then translate to 1 over 7 to the 6 times the reciprocal, and 7 to the 6 over 7 to the 6. Again, ask yourself, are there more 7's in the numerator or are there more 7's in the denominator? I would say neither, because they will all cancel each other out. So that just leaves me with 7 to the 0 power. And again, if you needed to, you could have written it out. But again, you would have 0 left over, so 7 to the 0, which would be your exponential form, which just gives you an answer of 1. Okay, what about number 10 here? Let's see, the opposite of 3 to -3rd, definitely going to simplify that to the 1 over the opposite of 3 cubed. because at a negative exponent, we did repeated division. And then here, because if there's a negative 2, we rewrote that as 1 over the opposite of 3 squared. So what does this all mean? It means this fraction is divided by this fraction, so I'm going to go ahead and write it like such. At this point, I'm going to go ahead and change this. So notice you can totally write across, but for this particular step, you will notice that I always write it underneath. And the main reason that I do write it underneath is so that I can check whether or not I am taking the reciprocal. Okay, so here I am going to take the reciprocal. It's the opposite of 3 squared over 1. So it's just my way of kind of confirming, am I doing the necessary steps? Because a lot of students here forget to take the reciprocal. So now I'm left with the opposite of 3 squared over the opposite of 3 cubed. Here, just go ahead and say what's a negative divided by negative? Positive. So you're just technically left with 3 squared over 3 cubed. Are there more 3's in the numerator or are there more 3's in the denominator? I would definitely say the denominator. How many more are there? Just 1. So you could write the 1 power, but it's not necessary, so I'm going to leave it off. So my answer is going to be 1 over 3, which would be my exponential answer, but my evaluated answer will also be 1 over 3. Okay, so moving on. Number 11. So here are just the steps if you needed it. Number 11 here, 4 squared, that's a positive exponent. Not going to have to deal with that, so I'm going to leave it as just 4 squared. But 4 to negative second, well, that is a negative exponent, so I'm going to have to divide. So we have 4 squared over 1 over 4 squared. Now I'm just going to take a pause for a second. I hope that when you look at this problem, you don't jump to the conclusion, oh, my answer is 1. Because these are not the same things. We have 4 squared and then we have 4 to negative second power. Those are two different things, so you can't just assume, oh, my answer is 1 or negative 1 for that. So please make sure you understand the difference. And if you are hesitant, just go with writing everything out the long way and figuring out were you right or were you wrong. Okay, so going back. Here, what does this mean? It means 4 squared divided by 1 over 4 squared. So notice here, again, to make things nice and clean, I went ahead and put 1 over the 4 squared to make it into a fraction. So now this is going to change. Again, I'm going to go ahead and write it underneath. This is going to be 4 squared over 1. This is going to change to multiplication. And of course, I'm going to take the reciprocal of this, so that's going to leave me with 4 squared over 1. So now I'm left with 4 squared times 4 squared. What's 4 squared times 4 squared? I have 4 altogether, so that's 4 to the 4th over 1. Now, do I really need to write over 1? No. So this is going to be my answer in exponential form, but of course, you're also going to have to evaluate it. 4 to the 4th power, I believe, is 256. Okay, so hopefully you're getting a little bit more comfortable with this. I know that some of you have developed shortcuts and things like that. Just make sure that what you're thinking, make sure it works every single time. And it's true, there technically is a quote-unquote shortcut. They're called properties for exponents, and that's going to save you some time. But I don't want you to use them until you actually see that pattern and understand why it's working. Okay. So now, moving on to number 12 here, we're just going to go ahead and write it as 1 over 3 to the 4th. That's going to change to 1 divided by 1 over 3 to the 4th. And again, you're going to keep seeing me write each number as a fraction to keep things nice and clean. So now it's going to turn into 1 over 1 times the reciprocal, which is 3 to the 4th over 1, which is now just going to leave me with 3 to the 4th. So that's my exponential form, but to evaluate it, I'm going to go ahead and multiply it all out, and that's going to give me 81. Okay, number 13 here. Look, it's negative 2 to the 4th power, so I'm not going to have to do anything with that. And negative 2 to the 3rd power, and again, I'm not going to have to do anything with that simplifying wise because they're already positive exponents. Now here, again, you can save yourself a lot of time How? By asking yourself this: are there more negative 2's in the numerator, or are there more negative 2's in the denominator? Hopefully your answer is there's more negative 2's in the numerator. So you would write a negative 2 in the numerator. Now, how many more are there in the numerator than there is in the denominator? There is 1. So do you really need to write a 1 there? No. So I'm just going to go ahead and leave it out. Now, once you start doing that, you're going to find that all of the negative 2's in the denominator would essentially be reduced and just leaving me with 1. So I would write a 1. But of course, to keep things correct and completely simplified, I would just say my answer is a negative 2. Now that's going to be my exponential answer, but what would it be evaluated? Well, it's just negative 2. Now here, do you really need the parentheses? Truly, not really, but because we're asked to write an exponential form, this just confirms that my answer is indeed a negative 2. Okay, but let me show you real quick by extending it out to see what you would end up with. You're going to find that you still end up with the same answer. Negative 2 to the first power, which is just negative 2. Okay, so now we have some more examples. I'm actually going to have you pause the video once again and try numbers 14, 15, and 16 by yourself. Now look very closely at the instructions here. It does ask you to leave it in exponential form, so definitely do that. Okay, so let's see how well we did. Here, hopefully you kept this as 2 to the 6th. Over, well here we have negative exponents, so that's going to be 1 over 2 to the 4th. I'm going to rewrite this as 2 to the 6th divided by 1 over 2 to the 4th. To keep things neat, I'm going to go ahead and make this a fraction as well by putting it over 1. Now I'm going to change this into 2 to the 6th over 1 times the reciprocal. So now we're going to have 2 to the 4th over 1. So here we're left with 2 to the 6th times 2 to the 4th in the numerator. So how many 2's are there? There are 10. What about the denominator? It's just 1. So I'm just going to leave it. There's no point in writing a 1 in the denominator. So this is my answer in exponential form. Now you might understand and see why we asked you to leave an exponential form, because do you really want to multiply 2 out 10 times? Probably not. So usually we ask you to write things in exponential form because we don't want you to have to go ahead and multiply all of those numbers repeatedly so many times. Okay, so now let's take a look at number 15 here. Since we have a positive exponent, we're going to keep it like that. Since we have a negative exponent here, I'm going to rewrite that as 1 divided by 10 2 times. This is now going to become 10 to the 4th divided by 1 over 10 squared. Again, to keep things nice and neat, I'm going to go ahead and make this into a fraction. So now we're going to be left with 10 to the 4th over 1 times the reciprocal. So I'm going to go ahead and flip over this fraction to 10 squared over 1. So now I see here there's 4 in the numerator and 2 in the numerator, so altogether there are 6. And there is just a 1 in the denominator, so I'm going to leave it as that, and that is going to be my answer. Now, last but not least, here we have 5 to the negative 5th power, so I'm going to write that as 1 over 5 to the 5th divided by, well, this is going to stay the same as 5 to the 8th. Now this is going to be rewritten as 1 over 5 to the 5th divided by 5 to the 8th power. Again, to keep things nice and neat, I'm going to make this into a fraction as well, putting it over 1. So now this is going to change to 1 over 5 to the 5th times the reciprocal, which is going to be 1 over 5 to the 8th. So here, multiplying straight across, 1 times 1 is 1. So notice here we can't leave off this one because it's actually a numerator, which makes a difference. Now in the denominator, we have 5 here and 8 here. So how many 5s do we have all together? We have 13. So this would be my answer in exponential form. So that is actually going to conclude our lesson for today. Thank you so much for tuning in. And as always, until next time, bye.